a physical quantity like length, mass, and so on, kita boleh express in the in dimensional expression. Why? Because we want to do the dimension analysis. How? Macam mana kita nak express in dimension analysis? In some capital letter. I will touch this after this, but before that, you need to know why you need to learn dimension analysis. The first reason is we want to find the unit of some equation, some new equation. Contohnya lah, you are a new scientist and you find an equation of force, which is selepas derive, you know that the equation of force is equal to ma. Now, we want to know the unit for this one. Before the unit Newton. Newton is the equivalent unit. Sekarang ni kita nak tahu dalam bentuk mass dalam kg is acceleration dalam meter per second square. Kita nak tahu dalam tu lah. Which is, yang ini memang nampak senang. kg meter per second square kan. But what if you have a new equation that it has long what we call long equation lah, long equation, which is you doesn't know it for sure what is the unit, then we will use dimension analysis to find the unit. The second part is we want to know the homogeneity of an equation. So you know that the equation of, let's say, S equal to UT plus half AT cubed. Let's say AT cubed. You know that the equation is not correct. Incorrect equation because you already learned that it is T square. But if you are new to this equation, konon-kononnya you adalah physicist yang first time jumpa equation ni. How do you want to know that this equation is correct? First, of course, by experiment. And then second, it is by the dimensional analysis. Alright. Any physical quantity, this is either we have derived and another one, base quantity kan. So either it is derived or base, we can express it in the term of something like m to the power x, l to the power y, and z, t to the power of z. So x is a numbers. Any numbers lah. And this m, l, t is the dimensional expression. Okay. Now, dimension of a derived quantity. Apa-apa yang derived quantity ni, kita boleh obtain daripada formula dia. For example, we have V. We want the dimension of V. What is dimension of V? Right? Let's look at this. Before that, you need to know the basic dimension for a base quantity because all of derived quantity is coming from the base quantity. So you have mass. Mass, the symbol of mass is small m. Okay, small m. When we want to talk about dimension, we need to put a square bracket. So this symbol, m is mass. Okay, but when we put a square bracket, it is said this is dimension of mass. Okay, dimension of mass. To simplify it, dimension of mass adalah capital M. Same as length. Anything. Kita ada small l, kita ada distance, kita ada displacement. All of this, its dimension symbol is capital L. Okay. When we put it as a symbol, we need to put a square bracket to state that it is dimension. But when we put it as symbol, as its own symbol like capital M and capital L, you don't have to put the square bracket. And then we have time. The symbol for time is T. The dimension of time is capital T. For electric current, the symbol for electric current is I, or some book use small I. and its dimension is I. Why we put dimension, we simplify the dimension, we want it to write its more neat, more kemas lah, neat untuk kita tulis. For temperature, tengok ni, capital T with square bracket, okay, is dimension of temperature, and we have theta as our dimension. So look at the difference. If it has a bracket, it is dimension for temperature. If it doesn't have the square bracket, it is dimension for time. And then last but not least, we have number of mole, which is n, small n, and it is dimension is n. All right, now let's look at the example before, which is we have V. All right, okay, let's look at this. V. The equation of V is distance divided by T. So distance, now we want the dimension of V. So we need to find the dimension of D and divide dimension of T. Okay, then we know that the dimension of distance is capital M and dimension of time is capital T. So when we simplify, we have the dimension for V is LT minus 1. From here, we can conclude the unit for V. So L is length, the dimension of length, which is the unit is meter. And T is dimension of time, which is the unit is S minus 1. So the unit of V is meter per second. This is simple equation, which is you already know. But if you have a longer equation that you doesn't know the unit, you can use this to find the dimension analysis. And then, for example, we have force. I want force. Let's say force. Okay, force F equal to ma. So I want the dimension of F equal to dimension of m and dimension of A. So you can find the dimension of A by using equation of A equal to V over T and do again this step. Or if you have a longer equation, this is just some example, you can find the what we call the dimension of A by looking at the equation by looking the unit. So unit for A is meter per second minus 1. So you can do like LT minus 2. This shortcut is available. You can use this shortcut only if you have this kind of equation, which is you have another one. This is for another dimension, and then this is quite longer dimension, which is LT minus 2. You can find using the unit just for the shortcut. But for example, this one, you have V. You cannot write like this. V is equal to D over T equal to meter per second. Then you conclude it L minus T minus 1. Salah you kena dapatkan daripada dimension pergi kepada unit, bukannya daripada unit kepada dimension. This is just a shortcut sahaja. Alright, so our M is mass, capital M, and our A is coming from the shortcut that we do just now. So you have the dimension for F is MLT minus 2. From here, we can conclude the unit, which is its mass, the unit of M is kg, the unit of L is meter, and the unit of time is S, so S minus 2. So this is your unit for the forces. Alright, so this is some example of the dimension analysis. You can try to do by yourself to prove that your dimension is something like this by using this equation. For example, this one is F over A. So F tadi kita dah dapat bahagi dengan A is length square. So prove that you can get this from the equation, right? Some of the equation doesn't have unit because if you can see, this is macam string ni kan. Change of length, dia punya dimension adalah, dia punya equation adalah delta L. Bahagi dengan L. Delta L tu length final minus length initial. So dia punya, when we find the dimension, it is L. And bahagi dengan L. So it doesn't have unit. Doesn't have dimension and doesn't have unit. The second part, the second part of the dimension analysis punya kegunaan, the uses of dimension analysis is to know the homogeneity of an equation. Okay. Equation tu kalau dia not homogeneous, tak follow ni lah, not homogeneous, makanya equation tu salah. Tetapi kalau dia homogeneous, dia tak semestinya betul. Tak apa, kita tengok homogeneous je. Let's say you have V equal to U plus AT. You nak tengok equation ni homogeneous ke tak. So syarat pertama untuk tahu dia homogeneous ke tak, dia punya dimension for left hand side dengan dimension for right hand side is correct. So you have 3 now. Okay, you ada 3 sekarang. V, U dengan AT. So the dimension of V is coming from the equation d over t, or you can look at the unit, which is you have LT minus 1. And then you have U, same, U is also a velocity, which is initial velocity. It also have LT minus 1. So for AT, this one you need to show the calculation. It's A times T. The A is LT minus 2 and T is T. You simplify this, you get LT minus 1. All of this, you can say that the left hand side, your left hand side, your left hand side is V got LT minus 1. Senang tulis macam ni lah, malas nak tulis banyak-banyak. Okay, you have this as your left hand side and this part is your right hand side. So all of these have same dimension. So you can say that left hand side equal to right hand side. Then the equation is homogeneous. Right? Okay, let's look at another example. The one that I given yang depan tadi, the first part. S equal to UT plus half AT to power of 3. So the dimension of left hand side is L. Dimension of right hand side, you have UT. See how I write the step. You need to write like this. So U is the initial velocity. You will have time T, you will get L. So yang ni betul. But the other one is you have half AT to power of 3. You will get something like half. Number also you need to find the dimension. Just that for the number, you will have the dimension is equal to 1. Okay, A is LT minus 2. When you convert it to dimension, you doesn't have to use square bracket. Tak boleh guna pun. You memang kena guna circle bracket. Macam tu lah. So T is T to power of 3. Right? When we solve this, you will get LT. Which is, by conclusion, this part is the same, left hand side, right hand side, but this right hand side is not the same. So this one is L, this one is LT. Should be, tak boleh tambah pun sebab dimension dia tak sama. That's why you can say that your left-hand side is not equal by right-hand side. Okay, then the equation is not homogeneous. Okay, satu lagi. Contoh yang saya cakap tadi, kalau dia homogeneous tapi equation dia tak semestinya betul. So let's say you have the same equation, ut plus at squared. Okay, you know that this equation is not correct, right? But it is homogeneous. Okay, we have S, which is S equal to what we call S is equal to L. Okay, then you have ut. I have calculated this before. You will get something like u is lt minus 1. This is t, so you will have L. For a t square, you will get a t squared. So what happened here? Your a is L minus 2 times t to power of 2. You will get L. So from here, you can say that your L left hand side, this one, is equal to this one, right hand side. Okay, the dimension of left hand side is equal to dimension of right hand side. That means the equation is homogeneous. However, the equation still incorrect. So how do you determine the equation correct or not? Lepas you dah tahu dia homogeneous, kita akan guna eksperimen lah. Eksperimen untuk tentukan equation ni betul atau tidak.